Hello students, welcome to the science lecture of grade 9 and we are discussing gravitation chapter. In the first video lecture we discussed up to this slide number 8. So now we will proceed with slide number 9 and on slide number 9 you can see that mass and weight. Many a times we get confused that is there any difference between mass and weight? So yes. So over here you will come to know about that difference. So first of all, if you focus that a mass of a body is the measure of its inertia. So what is inertia? In chapter 9 you must have studied about inertia. Inertia is a property of any object. If that object is at rest, then it will try to remain at rest. And if an object is in motion, then that object will try to continue its motion until an external unbalanced force is applied on it. So according to that concept over here, measure of its inertia, that is mass. In simple words, if I tell you, then total amount of any material, that is mass. But when the same object is in the influence of gravity, then we will get the physical quantity that is known as weight. And due to this only, weight is equal to force. Dear students, please focus on the formula. Force is also mass into acceleration, and here weight formula is mass into gravitational acceleration. In simple words, we can say that weight of any object is nothing but result of gravitational force on it, whether it has a little mass or a bigger mass. But gravitational force is exerted on it, and due to the effect of gravitational force, we are able to measure weight. And so this machine is known as weighing machine, because that will tell us the value of weight. Whenever we use weighing machine, we are under the influence of gravity. Without influence of gravity, we cannot have any place on this earth, right? But definitely one thing is very important, that if you consider earth, we know very well earth is not exactly circular. So if I draw over here, then earth is like this. Okay, say for an example, this is the diameter. Then it is said that the distance between the horizontal line and this vertical line, there is a difference of 21 kilometers. Dear students, if I tell you that, say for example, this is the center, right? Then from this center, this distance, for example, this is North Pole of Earth, and here is the South Pole of Earth, right? And this is the equator. So from center, if we think, then center to equator and center to North Pole, there is a difference, right? So more distance, less gravity, and less distance, more gravity. There is a famous question in many reference books that we should not buy gold at the poles. Students, can you think why? Yes, you are thinking correct, that North Pole is nearer to the center. So more gravitational force will be exerted due to less distance. And so more weight will be displayed in weighing machine compared to other places. Here maximum force due to gravity will be exerted, right? So these are the typical exam questions that can be asked in many competitive exams also. Okay, So SI unit of mass and weight both is kilogram. Okay, and its symbol you know very well, kg is its symbol. So weight of a body is force with which the earth attracts the body, and these are the formulas that I already told you. Since g at a place is constant, generally gravitational acceleration value is 9.8 meter per second square. It is constant throughout the place, right? If we simply go from equator to pole, then that is a different case. But at local level, that will not change. So generally, we do not consider the difference between mass and weight in practical life, routine life. But according to formula, there is a difference. And Newton is the SI unit of force, but the same unit can be used for weight also, because as we discussed just now, weight and force both are same. Moving on to the next topic. So weight of an object on the earth is the force with which the earth attracts the object, and the weight of an object on the moon is the force with which moon attracts the object. Definitely moon is smaller than earth, so its gravitational force is also less than earth, right? Mass of a moon is less than mass of earth, so moon exerts lesser force on objects than earth. Weight of an object on moon will be 1/6 of its weight on the earth, right? If we compare the weight on earth and weight of the same object on moon, then weight of that particular object will be 1/6 than the weight on earth. Dear students, question may arise in your mind that how can we come to know that it is exactly 1/6 only? So there is a simple calculation that weight on earth upon weight on moon, and on right hand side we have to substitute the values of mass of earth, mass of moon, radius of earth and radius of moon, right? In that way if we calculate, then we will simply get this relation 1/6. Okay. Now the next topic is thrust and pressure. First of all, thrust is the force acting on an object perpendicular to the surface. If any force is acting perpendicular to surface, that is known as thrust. When you stand on loose sand, the force, that is actually our weight of our body, is acting on an area equal to the area of our feet. When we lie down, the same force acts on the overall body surface area, right? So when we lie down, more surface area, so less force. And when we stand, so only our feet, or we can say sole of shoes, are in contact. So this surface area is very less compared to the whole body surface area, right? So this is how force exerted on particular area changes. We can have many examples. For example, if we compare iron nail and our finger, iron nail has very sharp edge, so very less area, so more force in less area. And at the same place, if we try by our finger, then our finger may not get inserted in that particular wooden box or wall because of our more surface area, right? So in that way, if we think, then thrust is perpendicular force itself, nothing else. And that particular force on particular area is known as pressure. So in iron nail case, very good pressure can be exerted when we just hit it by a hammer. Okay, so that is due to less value of denominator, more pressure will be exerted. So iron nail or soft board pin can easily get inserted, right? Whereas our finger is not possible, or even marker, pen like objects are not possible to be inserted. So this is the concept where pressure is very much important, and this is the only reason why the cutting tools are having very sharp edge, because sharp will be the edge, less will be the area. Okay. Yes, here this thrust is force, its SI unit is Newton, and area SI unit is meter square. So pressure SI unit is Newton per meter square. And if we write the meter square in numerator, then its power sign will change. And its another SI unit is also called Pascal. Its symbol is capital P, small a. Now dear students, if we think for pressure exerted by fluids, then first of all question may arise, what is the meaning of fluid? So in fluids, liquids and gases both are considered as fluid. Okay, now if we consider liquid and gas filled in any vessel, then both of these states of matter will exert force on the walls of that particular container. So how it exerts force, that we are going to study. First of all, fluids exert pressure on the base and walls of the container. Fluids exert pressure in all the directions. Pressure exerted on fluids is transmitted equally in all the directions. Okay, if we have a bottle and in that bottle we have filled simple water, right? Now, same type of 2-3 bottles if we keep by having same level of water, and in first bottle we have to make hole and nearby the cap. In second bottle we have to make hole in the middle of the bottle, and in third bottle we can make hole nearby bottom. Dear students, you must enjoy this activity and you will observe that the hole, if the hole is very much nearer to the base level, then with force the water will come out, and the hole which is very much nearer to the upper part, cap area, then with very less force the water will come out. So it shows that in liquids pressure increases with depth, right? You must have enjoyed all these activities in your previous classes because the things are included in our syllabus in grade 6, 7 and 8. Okay. Now the new concept that we have over here is buoyancy. It is also known as upthrust. Please remember, buoyancy is a property of any liquid. So what happens with this property? Any object, if it is immersed in water or any fluid, then that fluid or water itself will exert force in upward direction. Say for an example, if one student is carrying one very heavy weight object and suddenly someone supports from the bottom of that particular object, so the first student will feel very relaxed. Why? Because someone is supporting from downside. Same thing happens when we lift something in swimming pool. Why? Because in swimming pool, water exerts force on that immersed object, right? So force, that is weight, is in downward direction, and buoyant force exerted by that particular fluid is in upward direction. So we will feel very lightweight whenever we lift any bucket filled with water, but until it is taken out from that tank of water, we will feel very light in weight. But as soon as we take it out from the surface of water, we feel the actual weight. So these are the things that we can observe in our routine also. So when an object is immersed in a fluid, it experiences an upward force called buoyant force. This property is called buoyancy or upthrust, right? All the fluids will have this property, okay? And this is the only reason why all these ships float very easily. Okay, dear students, we can have one more activity, that in one glass we have one wooden block, small wooden block, and in the same glass, same fluid, but now we can take iron nail. Okay, definitely you will observe that iron nail will sink, whereas wooden block will float. Dear students, can you predict the phenomenon which is responsible for this? Yes, definitely density is responsible. Okay, so what is density? Density means mass upon volume. Mass upon volume is the density. Okay, if volume is more, means denominator value is more, then density will be less. Okay, if we are comparing two objects having same mass, then volume can be changed. And in that way, for example, iron nail weight is 10 gram and this wooden block weight is also 10 gram. So we can say mass is almost 10 gram, same, but volume is different. Iron nail has very less surface area, right? Whereas wooden block has more surface area. It is wider than iron nail. So more is the surface area, means denominator we have increased, so the density is less, and less dense object will float. Dear students, definitely here density of that particular object must be less than density of water, then and only it will float. Okay, and density of water is 1000 kg per meter cube, kg per meter cube. Okay, here I am unable to type 3 power, but you can understand kg upon meter raised to 3 power. Okay. So dear students, this is all about density, then after buoyant force, buoyancy, right? Now related to the same concept, we have one new phenomenon, one new theory, and that is Archimedes Principle. Archimedes Principle states that when a body is partially or fully immersed in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by that object. Say for an example, a very heavy object is thrown into swimming pool. Then how much buoyant force will be exerted on that heavy object? Yes, according to statement, the water that is displaced outside the swimming pool, that much force will be exerted on that heavy object by water present in swimming pool. So how can we check all these things? See, here we can check all these concepts. Okay. Everyone just observe that what is happening over here. Here LB is written. Actually this LB means Libra. It is derived from Roman. But for ease, if I tell you that this is pound. Okay, pound is the unit for mass. See, here you can see that 3 pound water is displaced by this object, right? So that much force is exerted by liquid on this object, right? So first of all, here in air, its weight is 7 pound. But as I told you that buoyant force is equal to 3 pound. So in air weight is 7 pound. Buoyant force means supporting from downside, it is 3 pound. So 7 minus 3. So in water, its weight is 4 pound. Right? Same thing we can observe over here also with different values. But meaning is same. Okay, instead of pound, you can take example by considering the units kilogram, Newton, etc. Okay. Archimedes Principle has many uses. It is used in designing ships and submarines. Hydrometers used to determine the density of liquids, lactometers used to determine the purity of milk. Dear students, these are most important questions, frequently asked questions in 9th standard. So please learn hydrometers for density of liquids and lactometers are used to determine the purity of milk. These are the applications of Archimedes Principle. Yes, density, as I told you, mass upon volume, and mass is measured in kilogram. Volume means area into one dimensional length, or we can say L into B into H. In short, 3 times meter will come. So kilogram upon meter cube. And relative density means density of a substance upon density of water. So this ratio is known as relative density. Dear students, please learn these formulas. These are extremely useful in many numericals. And here we can end our chapter with one very interesting fact, that an Archimedes principle, the Archimedes principle may have been used to determine whether the golden crown was less dense than gold or not. Dear students, just think upon it, that how this technique is useful, okay, and you will get one interesting understanding of Archimedes principle. Thank you very much.